James Pope here with RSA NetWitness Platform. We're continuing our series talking about the Mitre attack framework and visibility into your organization. Today we are going to discuss and go over the Mitre attack T1095. This would be a standard non-application layer protocol. In this particular one, we are going to use ICMP as our outbound. And what we're going to do is we just have a script that's set up, again, using Attack IQ, and where it's just going to enumerate some really basic commands from the user, what they have access to, who they are, what their IP address is, and what scheduled tasks are running. So diving over into NetWitness, after it's run, we're in the Investigate tab. We can see it's been filtered down to the host, which is our attack host. The host name is called attack. And we can already see some things popped out here from attack, such as discovery, enumerates domain, enumerates IP, enumerates local users, enumerates processes on local system. This sounds like exactly what we ran. And then we also see ICMP large session, which is likely our flag going out. So to start, I think, we can scroll down and find other things that are interesting, but I think to start, we'll just dive in on discovery. Pop that open, and we see our endpoint data coming in and some network data as well. We see our AI Python exe created a process called NetExe. We can go look at all of our metadata right here in the sequence, or sometimes I like to look at it alphabetically. It makes it easier to see where it's at, enumerate local users, all of this checksums, everything that comes with it. I want to find, there's one in here, the parent of it. So yeah, this parent parameters right here. This is showing that AI Python exe, also a main.py and a model.json, which we do have access again to all these files. We can download them. We could look at them. We could send them out to be evaluated. So at this point, I'm seeing those call outs, but I'd like to look at it more from the endpoint side. So I'm going to kick it over to pivot to our host overview. And this is the view for endpoints. I'll pull it back out just so you can see. So all the endpoints we have tied in here. We're looking at our attack one in particular. These are our things we've ran prior, earlier today. And then these medium ones right here, these ones we're looking for. So we have our enumerates domain group. And you can see here it is our... the command is the NetExe, looking for admin domains, NetExe exchange trusted systems. Any one of these you can expand, look at further, analyze process, which we're going to do in a minute, and kick it out and go look at it further. We have all the hashes and some of the high level metadata as well. And we see a group exchange trusted subdomain as well. NetExe, what user they are, again, what user they are. NetExe domain admins, seeing who they are, what they have access to. More of that. Who am I type of stuff. So at this point, again, what spawned what, who did what. So we're going to kick that out to an analyze process. Okay, so analyze process is going to kick us up that same type of tree we had. We'll go ahead and expand this. And already this view gives us a pretty simplistic view. Net user, domain, admins, trusted systems, IP config, and a task list. I think that was all the things that we had initially kicked off in the script. But we could say, view them all. I want to see everything. And you can see it kicked out what launches what in this scenario. So I think we have a pretty good grasp on everything we tried to run and enumerate. We'll dive back into that ICMP large session here, and we'll pop that open. And we have that one network connection. Actually, I think it was in there. Yeah, so this is that same one right here. So our large network connection, and we'll again filter this by alphabet, and we'll see that it's already being flagged as an ICMP large session. We can see the bytes right here is 13,000 ish. I think the average one's like 32. So this is clearly not a standard ICMP. The reason ICMP is used a lot is because organizations do a pretty good job with their firewalls for the most part, but they are really bad with DNS and ICMP because they just need to open them to make it work. And ICMP in particular, even things that are hardened and locked down, we allow them through because I need my what's up to tell me if my firewall goes down or my switch goes down or a host goes down or any server goes down. So a lot of it's uptime monitoring and just overall troubleshooting for sysadmins. But yeah, we can see it's being already flagged as potential exfiltration, maybe command and control. The only other thing I want to bring out is, it automatically gives us an entropy in here. Once we turn that parser on, which we have in this environment. But that entropy leads me to believe that this is something that could be manipulated, maybe figured out what happened. In this case, we're not going to go through the effort because we already know exactly what was exfilled. It was the users, the scheduled tasks, and what the ICMP protocol is. So yeah, coming back to it, in your environment, again, running another technical ID against it. In this case, we are sending something over a ICMP protocol, and we're seeing if we have visibility into it, which the cool thing about ICMP, it is all in clear text, but they could send other stuff in there. So what would I do to go further in this scenario? Maybe I need some better firewall rules to limit ICMP traffic that's above and beyond, standard ICMP with error reporting, in which case this one would be drastically over that. Maybe it's an auto rule that anytime I get anything with ICMP above, I just want to get an alert, create a ticket on it, maybe just block it automatically, go to the endpoint, and maybe certain discovery tools in a row get auto flagged, auto blocked, take it further. With that said, that wraps up this video. Continue your happy hunting, and thank you.